We have a question on differentiation of implicit functions. 1 plus x squared into brackets 1 plus y squared minus ps squared is equal to 0. Where p is a constant, we are supposed to show that xy into brackets 1 plus x squared dy dx is equal to 1 plus y squared. So let's go ahead with the solution. Now let's consider this as our equation 1 and go ahead and expand this part of the equation. Now, the designation dy dx over here gives us a clue as to the direction the solution should go. And so let's go ahead and differentiate this expression. 1 is a constant, and when you differentiate a constant, is 0. So let's go ahead with the rest of the terms of the expression and differentiate them. Now, this is a product of x squared, y squared, and to differentiate this expression, let's apply the product rule. And by the product rule, given y is equal to uv, then dy dx is given by the formula so if u corresponds to x squared, then du dx is equal to 2x, and if v corresponds to y squared, then so what this means is that when we are given an expression that is a product of two functions, we're going to maintain the first factor and differentiate the second, then we maintain the second factor and differentiate the first one. So the first term of x squared, we maintain s squared and differentiate y squared. And here, when we differentiate y squared, this is the expression that we are going to get. Then we are going to maintain the y squared and differentiate the s squared. And so let's go ahead and plug these values into this expression. So we maintain the x squared and differentiate the y squared, which is this expression here. Then we maintain the y squared and differentiate the s squared. Then we go ahead and differentiate the last term over here. Now, you can see that 2y dy dx is common to this first term and is also common to this third term. So let's go ahead and factorize 2y dy dx from the first term and the third term. Then we maintain the rest of the terms. We reorganize them. So you can see that the factor 2 is common to all the terms here. So let's go ahead and divide through this expression by 2. So we're going to get so let's move this term to the right side of the equation. Now, if you look at the left side of the equation that we have, this left side, this expression, and we compare to the equation that we are supposed to show, you can see that the only difference between the two is the presence of this factor x. So let's go ahead and multiply through this whole equation by x. So we're going to get if we look at equation 1, we can rewrite this equation in such a way that 1 plus s squared into brackets 1 plus y squared is equal to ps squared. From equation 1, we can say that so at this point, we would replace this whole expression here. So the equation would now look like this. In other words, when we choose to expand this, we're going to have so at this point, this will cancel this out, and this will cancel this out. And so we're going to be left with and if we are to look at what we are supposed to show, it is exactly what we are supposed to show. So we have been able to prove that if we are given 1 plus s squared into brackets 1 plus y squared minus ps squared is equal to 0, where p is a constant, has successfully been shown that xy into brackets 1 plus s squared dy dx is equal to 1 plus y squared. Which is this expression that we have gotten here. So that is the end of my video. Thank you very much for watching, but keep watching.